Of course. Let me start recording. So, good morning, everyone. Thank you for being here. I'm sure more people will trickle in as the hour progresses. So, welcome back after a week break. Today, we have Jen. They will be presenting chapter 8, which is on conditions. Which I think should be pretty interesting. I was reading through it, and it was not the type of, I don't know, I guess I was thinking of conditional logic, and it's more about, uh, you know, warning messages and whatnot. So, I'm excited to learn more about this. So take it away, Jen.
Thank you. And just full disclosure, towards the end, I was running out of time and couldn't complete all the exercises. And I also thought it was a bunch of if statements, and I was like, oh, this is going to be super easy. But no, this is about errors and conditions. And just to clarify, conditions, so function authors use condition signals the condition system to signal to the user that something unusual has happened. So we're talking about errors, and the author found some inspiration to write this from these two resources, which you can look at if you're interested. I, of course, failed the quiz, so this is a good chapter for me. We're going to make use of the RLang library quite a bit to do some inspection. So signaling conditions. So there are types of signals and the severity. So the most severe are errors, followed by warnings, which are severe but we partially recover, so the program doesn't necessarily exit in comparison to errors. And there are also messages, which are the least severe, and they're mostly to inform the user. There's also an interrupt, but we don't it's not interrupts aren't really discussed here, since this is usually user initiated, I guess. So this is just some examples of what they look like. And most of this code is not in this session is not runnable. I mean, it's runnable to some extent, but every time I try to run it, it's causing an error. So you're going to see that I tried to set everything to val false so that it wouldn't run. So we're going to first of all talk about errors. So in base R, errors are thrown by stop, the stop function. And they include a call, which is not very useful, but we can get it via using the function traceback if needed. The author suggests using setting the call dot argument to equals false, which RLang BORT does by default. So this is what using stop looks like. So we have this message here. This is what the stop is saying. So this is the message passed, and then we have this is the call that is not supposed to be very helpful here. And we can see later that the call is reduced or removed in the second function. And then here, this is these two are very similar because the call is set to false and we use abort. All right. There's also a note that I guess stop pastes together multiple inputs while abort doesn't. This means I could do something like, I think, sorry, if we go up here, I could just make some other thing and it would paste these together. That's what he's talking about. But abort doesn't. And the author recommends using glue, which we'll see examples of later on in this chapter. So I liked this comment exactly as it was. The best error messages tell you what is wrong and point you to the right direction to fix the problem. I agree with this. There's a link to the Tidyverse error style guide for recommendations on how to write error messages. I'm in the middle of troubleshooting an error that doesn't tell me anywhere about where it's coming from. And is like, I think I wish that whoever wrote that error would have considered the person who leader needs to understand the error to fix the code. So next up is warnings. Um, Warnings, unlike errors, there could be multiple warnings in a single function, so they all get cached and then printed when control returns to the top level. So we can see that happening here. We have multiple warnings that are happening, and if this was, the stop function, at the first stop function, the whole the code would stop execution, but here we see that it's continuing, so we see all the warning messages. If we wanted to do some troubleshooting, because, if we were just looking at this, we don't know exactly where's the issue. So what we could do is use this option, warn equals 1, to make warnings appear immediately. We can also turn them into errors if we wanted to, by setting warn equal to 2, and then we can restore default behavior. This is helpful for troubleshooting. Similarly, we could, did I spell suppress wrong? Yes. You can call the, you can suppress the call with, again, call dot equals false. And similarly, our lang warn also sets the call to false. So the author reminds us that we want to try to balance what should be known and what should be fixed, and to practice restraint. And but makes the following points that they think the following errors might, or warnings might be better as following warnings might be better as errors, which I kind of agree with, because these are showstoppers in some sense. Like, you can't remove a file that doesn't exist. It's very gentle advice to the user. So warnings are appropriate when, for example, we're deprecating a function. We want to allow some old code to run while advocating a switch. And we also want to reasonably recover for a problem. So the least severe are messages. Messages are informational to tell a user that you've done something on their behalf. And they're displayed immediately, and they don't have a call dot. And I don't know if I'm saying this correctly. I'm just saying it as I read it. Maybe it's read a different way to more knowledgeable R people. So let's look at this example. So we see that as soon as a message is encountered, it's immediately printed. So it looks like everything is sort of in order. And then here's some good use cases for messages. Messages are good when there's some share. I think I want to say shared. When we want to share, let me see, with the user a value used for a default argument that requires a non-trivial computation, or for function side effects, such as we're writing to a disk, we want to tell the user that we're writing to the disk, or before a long-running process, you might want to just say, hey, this function is going to take a while to download something, for example, or display a message that the package is loading, such as using a dot on attach function. functions using messages should have a suppression argument, like white equals true, for example. So there was just a note about the difference between cat versus message. So cat is used to print to the console because the user asked for some content, versus message, which is sort of a side channel to print to the console when the primary function is doing something else, but we just want to inform the user that, about something. So there's some exercises for this subsection. So can you remind me, do we go through all of the exercises, or should I just talk about the content?
I think it's kind of up to you how you want to cover it. If there's an exercise you find particularly compelling that you want to focus on, or if you think all of them are useful, or just what were some important lessons you got from the exercise, it's kind of up to you.
Okay, thank you. I think I think this exercise is not too hard. There are some other ones that are a little bit harder that maybe we can go through together. So I'm gonna skip that, but they're gonna be included here.
Could I make a comment about that
Sure.
file and or remove function?
Yes. Yes.
It just reminds me of how in the past we've had discussions about the security of bioconductor packages, and this was one of the examples that came up in those discussions, was how someone like a package developer who wanted to put malicious code on a user's computer could just do something like this, like they could rename or they could redefine a function to just put a file.remove in it and delete users' files, for example.
Oh, wow.
It's fairly easy to do if you have someone with who somehow gets access to the Git server. I mean, we have so far had only people with good intentions, but I don't know. It's something that we've never had to deal with. I think that was part of the motivation for BioC Manager, whereas before it was just this source BioC Lite that had some increased risks of, someone using a similar domain name or something and tricking someone into sourcing a different bad BioC Lite.
Does I'm wondering if BioC Managers does some sort of checking for malicious code. I'm wondering.
No, well, Marcel could tell you no, but at least it's hosted on CRAN and it's not sourced. Like you have, when your average user installs it, it gets installed from CRAN as opposed to sourcing it where it sources from whatever URL you put in that source command.
Yeah, so if you type out that source command and someone had a malicious file where it was BioC Lite, but it was with a capital I instead of a lowercase l or something, they
Oh,
could
wow.
technically run malicious code.
Yeah, or just, if someone got bioconductor with a bioconductor.org with a misspelling,
Yeah.
bioconduct ER or something, and then
Yeah.
started, posting advice on Stack Exchange or something, giving this misspelled URL. It's a way to get code onto people's computers. And something like this is an example of how, you have a lot of power inside an R function.
Yeah. Thanks for those comments. The thing that's scary about like errors or failures is like malicious intent. So
Yeah.
this is a good scary scary chapter.
Yeah, I mean, if you wanted there, instead of file.remove X, you could put, file.remove dot and recursive equals true.
That's mean.
Yeah. Yeah, so, don't trust all code you find on the internet.
No. Okay. So I'm just gonna continue here. Let me see. So we're gonna go to ignoring conditions. So we use try for errors and suppress warning for warnings and suppress messages for messages. If you want, what's it say? If you wrap a statement that errors in a try, it will error in execution will continue. Okay. So here, let's see. I'm just reading my code. So, or the code. So we're just the error error is noted and it continues execution. Normally, we're going to talk about execution stopping at some point. Okay, here we are. So we use a try catch to perform different actions based on the success of the code. So a useful pattern is assignment inside of the call. So we have just this default that's defined here as null. And then this is the code we're going to try to execute. And then, oh, I see. We're gonna and just like let's see. I think I can run this code. This could be okay. Let's see what happens. Warning cannot open because there's no file that exists, right? So we get an error, right? And then here's examples of suppressing warnings and suppressing messages. So no warnings are printed here, no messages are printed. And then handling conditions. So this is the default condition behavior. So errors stop the execution and return to the top level. And this flow of, where's control go is kind of important, will be mentioned a couple of times. So errors return to the top level. Warnings are collected and then displayed in aggregate, and then messages are displayed immediately. So we're going to talk about the try catch and also with calling handlers, and they allow us to register handlers. So these are functions that take the signaled condition as their only argument and temporarily override or supplement the default behavior. Try catch defines an exiting handler. Exiting handlers, after they capture whatever it is, the control returns to the content where it was called, and it's going to exit. So it's most suitable for errors and interrupts. Whereas with calling handlers, they define a calling handler. So after capturing the condition, the control returns to the context where the condition was signaled. It's usually used for non-error conditions. So looking at the condition object, if we want to see what this is, we can use, again, the rlang package that has the function catch CND, or the condition catch condition, to inspect the condition object, which is created implicitly when signaling condition, but it's made more explicit inside the handler. So we can see here that when we catch the condition that's signaled by this stop function and inspect it, we can see that it's a list that has two things, which is a message and then also the call. And if we want to, for example, extract the message, this message that's here in this condition, we can use condition message. And then if we want to extract the call, we can use a condition call. And I'm not sure where these functions come from. Condition call. I just want to see what function does it come from? Oh, it's from base R. Or, sorry, I was just looking for the package. Okay. Conditions also have a class, which make them an S3 object. custom conditions can have additional components. So the base ones just have message and call. Exiting handlers. So as I mentioned, try-catch registers an exiting handler after their signal control and never returns to the original code. So it exits. If no signals are caught, then code executes normally. So in this example here, we have a function with a try-catch, and it tries to catch an error, and it'll return NA if there's an error. And the code that's evaluated is log. And this is just an aside, but to me, this pattern is so different from other other programming languages that I've used. Like my way of understanding the code is that, or coming from a perspective of someone who used other languages, is that I would see the code I'm going to evaluate first, and then the attempts to catch it, like following that. But this doesn't seem to be the pattern you use in R. So that's a me thing, not an R thing. It just, to me, isn't as intuitive as I would expect, and it has given me a lot of problems trying to use try catch and the other related functions. So we see here that when we call F3, we're going to do a bad thing by sending it a character X. So this is going to catch the error and then return NA, because that's what we want it to execute whenever there's an error. Then in this example here, we're just going to catch the message. So this is helpful to note that these in this pattern, these things should sort of match here, and then this is what you want to run instead. Whenever, for example, a message happens, this is like the body of the function. I feel like if you're not very new to R, you might want to see something like this, so that this is a function, but that's just me. And you want to, do something with the function here. Okay. So I just copied this like exactly as I read it, because I didn't understand very well what the author was saying. So he says the protected code is evaluated by the environment of the try-catch, but the handler code is not, because the handlers are functions. This is important to remember if you're trying to modify objects in the parent environment. So I think what he's saying is that, for example, if we have some code that's sitting outside here, this is just going to work on the content here. It's not going to, for example, if we had something like this, we had like some value here, something like this is not, like I can't set A here. This is different. This is not going to work. Like I want A to be there, that is not going to work, is what I think he is saying, but I could be wrong. Does anyone else have an interpretation of what, or a reaction to what you understood when reading that section? If you like, it's hard to remember a single comment like this, but if not, we'll just continue. So here's another example here. And I just wanted to note that the CND, this is the condition that we're talking about that's being signaled. So we don't know where this comes, like it's, for example, I think maybe I also changed some of the the examples so I can understand a little bit better and explain a little bit better. So I'm just noting here that this is condition. So remember, he said like it's made sort of implicitly, but then it becomes explicit. So this is where it sort of becomes explicit here, the condition, and then we can sort of handle it later on in the function if we want. There is also, in addition to having this, handling something, and also this code where we're going to be evaluating stuff, there is additionally, in a try-catch, a finally argument that you can set. And finally is always going to run. It doesn't matter if there's an error caught or there's no error that's caught. It's always going to run whenever this try-catch is evaluated. And then you can see here that the way it runs may not be exactly as you think it would. So it's actually going to run. We see that it's actually running before the stop, or this, sorry, this, it's run before this is run, because this, after catching the error, that's when we're going to stop execution completely. So the finally is going to be run before we stop the execution. So calling handlers. With calling handlers, of course, we're defining calling handlers. So this allows the code to execute normally after the handler returns. So it's good for non-error conditions. So let's look at some messages. We're going to try to catch a message. If we catch the message, then we're going to say we caught a message. So here's some messages here. So as soon as it sees this message, so you can imagine, like, this is the handler that we're trying to set, and then we have, when we try to execute the code, where the code is like, hey, I see a message, so it's okay. So it says, okay, I see a message, I'm gonna execute this guy, and then so it caught a message, and then it goes back to this part of the function. It's like, okay, someone's there. So that's why we see this order happening. And the same thing happens with this one. It's going to arrive here and it's going to say, whoops, I see a message. Okay, I'm going to catch this message. So we execute this, and then it's going to go back here and then finally execute this message here. Something similar happens here. So handlers are applied in orders, and this is sort of important to know, because we're going to see it's going to get more complicated. So we see that this is just as I mentioned. So when this code is executed, it knows that it's setting this handler here. The handler is just going to wait for us, wait for the signal, basically. So when it gets to message during execution, it's going to say, okay, I see there's a message here, let me execute this before this other message gets executed. So there's a little note that handlers signal conditions that can be caught by another handler. So you should just be aware of that. The return value of calling handler is ignored because execution continues. So calling handlers are only useful for their side effects. So one side effect is muffling a signal. So muffling a signal is we want to stop it from bubbling up. So conditions can bubble up. For example, as I mentioned, it's going to get more complicated. So it can execute, so they'll be executed in order, and also these conditions. So handlers execute in order and conditions can bubble up. So looking at this example, which we're going to use muffle to stop it from bubbling up. And this is, let me see. Yes. Okay. So this is an example where we can look at things bubbling up. So when this code is executed, we set this handler here to say level 2. That's going to catch a message. There's another calling handler that's set within the execution of the code section. So again, another handler is set within that, which is level 1. And then this is the code that's we're attempting to execute. So when this runs, so all these things are set, when we see this message here, we notice, okay, we're going to execute, we're going to catch this message. So first it gets catted here, and then it's going to bubble up. So it doesn't just stop here, it goes out to the next level, and then also catches the message at the next layer up. So we could see this keep going infinitely up before we actually run this message here. So the same thing is happening here. And then if we wanted to prevent this bubbling up, what we could do is use Erlang's CND muffle function to prevent the condition from bubbling up. And in this situation, what happens is that at the second level, we're going to muffle it. So this means that if we remember our previous example, the message gets caught here, and this gets catted to the console, and then we catch it in the next, the level above. We cat this message, and then we muffle it so that in the end, what happens is the signal is not here anymore, I guess. So call stacks. So if we want to examine the call stack, we're going to use CST from the lobster function, because the call stack for exiting and calling handlers are different. So we just have this example here of the functions calling each other, and at the end there's a message in the last one. So with this calling handler, we're using lobster here, and then the muffle function here. We're just seeing what this looks like. So what this should tell us is that calling handlers are called within the context of the call that is signaling the condition. So are called within the context of the call that's signaling. So that's within H, or right? Yeah. So this is within H, right? And then exiting handlers are called within the context of the call to the try catch. So this goes all the way up, right, to the try catch. So here are some exercises. So I thought this was useful to show what's the difference between stop and abort. And abort is from the Erlang package, or the abort function, and I think also the corresponding functions for message and warnings do something similar here. And you can see that the error message is a little bit richer in terms of providing more information versus stop, which is from the base package. And we can see that this is This is the type of error. It's an R-lang error, but I thought this is much nicer and informational than the stop. And then this is the answer to this question because I just ran it, but I think the important thing is this last one here. So we try to this exercise is we just want to predict what's the answer to the code, or what does it do, right? So we're trying to catch a bunch of things here, error, warning, message. And I think the key is to remember that you're using a try catch. These three are pretty easy. It's this one that's a little tricky. And what's going to happen is that it's going to, sorry, it's going to run this 10, but there's no problem. And then it gets to message and it's going to exit. And the reason it's going to exit is because a try catch defines an exiting handler. That means it's always going to stop after you catch whatever it is. So we're never going to get to warning. And this also was really tricky. So in the end, I ended up writing some silly code that looks like this. I don't know if you can see this, but this is how I tried to, sorry, this is me numbering the lines later, but I made some print statements to just help myself understand what's the order of things. What happens is that if we remember again that when this is run, because there's this, just noting that there's this inner calling handler, when we get to the message, it's gonna, we're going to see that there's this error message. It's going to be caught at this level, and then it's going to be caught again at this level. And then when it's caught here, and then it's run at this point, oh, there's another message. So it gets caught at this top level before it goes and runs this line here. And you can stop me if you have some questions about things. I felt like this is really, you have to sort of follow the, you have to think like how the code might be running, which I struggled with at some times. So if you have some questions, you can let me know. This is the source of catch-TND, but I was starting to run out of time. But I'm just going to continue since we have about 20 minutes, but we can come back to any of these and discuss them later. So you can define custom conditions. So up until now, we've just been looking at the built-in conditions, but you might want to write a custom condition because most R functions only just have, those built-in conditions only have a message and a call, and it's not very like information rich. So it's hard to, detect specific types of errors. You can write custom conditions with Erlang's abort function by supplying a subclass and metadata. And I wish that this subclass was a little bit explained more because but maybe that's not the point of this section, but I didn't understand it very well. But this is what it looks like. I'm trying to define a custom, sorry, before we get to defining that, this is the structure that the author recommends for writing errors. So we're going to first have the name or the type of the error. So this is kind of the name. So in this case, it's error not found, followed by some user-facing text, which is this message. So this is what the user is going to see whenever this error is, when the abort is signaled. So they're going to see path blah CSV not found. And then this is just some custom metadata for us, the programmer. So this is what they see when the abort is run. So here, let's talk about motivation. And I thought this section was really good because I honestly didn't know very well how logging works, but it's something that I know is pretty useful. So, we're going to use this base log function, and we'll see that it's not very helpful providing some feedback to the user. So for example, we're just going to send it some letters, and we see there's error, there's the call, and then non-numeric argument to mathematical function. So what does that mean? Who knows? I mean, it's not that bad, but okay. And then we don't know what's the problem with this next one, which we're sending a vector with basis letters, but which one is the problem? No idea. So we're going to improve the code a little bit. So we're going to write my log function, and then we're just going to check the arguments if it's in numeric. If it's not numeric, we're going to write x must be numeric of some vector, not some type of. So this is just some nice error messaging for the user. Although, just a minute. Like, he just mentioned using this pattern, but I don't see that pattern here. What? Okay. So, so we write this nice logging function here, and then the result is a better information about for the user about what's going wrong. So we have this, the problem is is X, and the issue is that should be a numeric vector, not a character, which is what we gave it. However, the useful metadata is a single string. So the problem that he mentioned about these custom conditions is that the metadata is a single string if you want to programmatically handle the error. So while this is good for interactive use, I guess there's still some issue if you wanted to handle things programmatically. So just to deal with looking at signaling, earlier we mentioned the glue package, which helps us to sort of glue together like parts of a string, for example. And so we're going to use this to create a nice error message, similar to what we've been doing. So here we have a function, abort bad argument. Sorry, I'm just trying to figure out where I am in terms of like there's only about 15 minutes left. Okay, I think we have enough time to get through most of it. We're just sort of using glue to piece together the parts of the message that we're going to give back to the user. So that's all that glue is doing. Like if this looks very like similar to Python, like I don't remember what they're called, maybe F strings, if you're familiar with Python. And we just sort of piece together you know, this message, and this is kind of like a placeholder for whatever that variable is. Right, so we make this, so this is sort of the pattern that we were describing before, which is this is the name of the function, or sorry, name of the error. This is the message we're going to send to the user that we have created up here. And then this is some additional stuff that is coming from here as well. So I guess if you don't want rlang as dependency because you don't want to for using the functions like abort, for example, you can create a condition manually. And this is how you do it, although it's a lot more code to do it this way. I don't, you know. Okay. So handling. So structured condition objects are easier to program with. You could use them for testing your function. So this is just an example of using signals again and handling them. And that's also how we sort of programmatically do unit testing, for example. So if you're not familiar with this construct, this is basically this is using the library testthat for testing. So this is that familiar catch condition. And then we're just going to, it's just testing. These are, you know, members of the testthat package. So for example, expect equal is just going to do a comparison, and it uses expects equals. Yes. Okay. This is just a note when using try-catch with multiple handlers and custom classes. The first handler may not be the best match for your the first handler may not be the best one for the condition that you want to catch. So you want to make sure that you order the most specific one at the top. So you can see here an example of trying to catch multiple things. We probably want it to catch this one because this is an A. We're giving it a letter A. And this is least specific, this other error, but instead we can see that this condition is going to be caught here. And that's why that's printed here. Okay, so in closing this chapter, the author just looks at some applications of using these patterns to help you write better code. So one example of using, you know, for example, a try-catch is to give the user to tell the user what's the value that failed. So for example, here's a wrapper to return a default value if the error returns. And I think all of these were pretty good to look at, and it's probably better than me trying to run through them in, you know, less than 10 minutes. These were some good examples to look at. And so sorry. We can see here that where were we? So we just tried to run some expression here, but let's say that this expression generates an error. So we want to give that value back to the user to say this, you could imagine like writing a more useful error message with this and saying, this value was problematic because of, something else. Here's another example using base try. Another pattern is success and failure values. So we're going to return a value if code evaluates successfully or if it fails. So there's the user should know what's the good value or the error value. So that's what the user is going to see as a result of executing this code. Another use of using conditions is maybe we want to resignal. And as we mentioned this earlier, you could use the options warn equals to turn a warning into an error, but you could also do this programmatically. For example, maybe we catch this warning here, or this expression triggers a warning, but this warning, for example, as typically happens, it seems in R, R tells us, oh, this warning is later going to turn into an error in the next version. So we usually have these flags that we put in our environment file, and it will change warnings into errors temporarily for the current version of R that we're running for Bioconductor on the builders. That way, maintainers can see this and then fix the code so that it won't, they won't be using this warning or this code that triggers a warning in the next release. So this is like something that typically happens. So here we catch this warning, and then we're going to change it into an error to make it more severe. So record another thing is if we want to record conditions for a later investigation. And let's see, I think I'm almost at the end. Oh, a signal condition that doesn't inherit from. So I feel like these last two are a little bit harder to understand, in that like recording conditions for later investigation. Since calling handlers are only called for their side effects, we can't return values, so we have to modify some objects in place. So we have this code here that usually the conditions are going to bubble up, but we don't want them to continue to bubble up here, but we want to later probably still capture all of them or some of them and then report them at the end. Okay, this default behavior. I think this is the very last one. There's like 4 minutes left. this is referring to logging, which again, I thought was pretty insightful to understand how logging works. So in this case that we had like something that was like a um, condition that was made. And sometimes in logging, you might have different intensities or levels that you want to log, like how much you want to log, for example. Is it you want as much information as possible, or you're just or you want to, for example, catch all the errors, or just share some informational message. So this is what this function is doing. And this is not going to, without something, okay. So by itself, like the logging is not going to do anything unless you you add something, you add a handler, for example, which is showing here. In this case, we add something to set the level so that stuff with info is shown. Oh my gosh, there's 2 minutes left. There's some exercises at the end, but I did not have time for the exercises, but maybe it's a good time to discuss anything that was
Yeah, I mean, I have a question.
question.
So as someone who is not, I mean, I've written a few, functions and whatnot for packages, but uh, I feel like you're more of a seasoned developer than I am, and I was wondering what were like the big take homes for you?
The big take homes.
Like, was there anything that like you learned from this? You're like, wow, I need to start doing that when I write code now.
Oh, yeah, I think in terms of the pattern, learning the patterns are really important, because it's not the way I learned to do things in other languages. I spoke about, the ordering to me is not intuitive, because usually it's like the expression that is evaluated, and then you try to catch it in the code that comes after that. But it seems the opposite in R to me. And even I remember, like, why couldn't I, like, I didn't understand the difference between like an exiting caller, exiting handler, and a calling handler. Like, I thought it's just some signal, and then like I can handle it however I want. I couldn't figure out, like, the first time I tried to write something with a try catch, why my code kept exiting when I was like, I'm catching it. why doesn't why doesn't my code continue? And then I found out I have to use this completely different function with calling handler if I want my code to continue. So I think this chapter is really useful if you want to be able to handle things that are unexpected. Well, to some degree, you expect they're going to happen because you're programming it, but you want to know how to handle that in a way that is going to be like helpful to the user, um, uh, so that your code becomes more predictable. Like I mentioned, I'm trying to troubleshoot where an error is coming from, and there's no clue. There's not, the call isn't even there, and there's nothing even that says error. It's just one line that says invalid connection, and I have no idea where it's coming from. So I have to sort of troubleshoot, like, where I could possibly find. In I think some of the functions that Hadley mentions, like using R-lang, I'm trying to use those to sort of investigate this, but I think the big take home is try to understand, try catch with calling handler so that you can better handle code execution, and then also try to write nice error messages that are helpful.
Thank you. Does anyone have any other topics for discussion? Thoughts on this chapter?
Definitely some stuff about calling handlers I didn't know about. I feel like I would need to actually do some hands-on work with them to really understand them, but they seem like much more powerful debugging tools than the just debug function that I've used in the past, and the options error equals recover.
Yeah, I agree. Like some of these like some of the exercises and some of like these last two I didn't understand very well and need probably a second glance to understand it much better. But I feel like reading this chapter made me a little bit better at handling errors. I just hope it makes me also better at like debugging them as well. Thanks everyone for following.
My just short comment is that I think this is a way for R to it's kind of, I think other software use like error codes to like signal any type of error and classify errors, but R doesn't really have anything like that. So we're stuck sifting through errors and trying to see which of those errors we can do something about. And I think that's what the major strengths of these functions.
Yeah, I wish R had some error codes.
Okay, well, thank you so much for presenting, Jen. That was extremely informative. I feel like every time I attend this book club, I learn there's just so much to R that I had no idea even existed. It's just like the unknown unknowns, the things you don't even know that you don't know. So that was great. Thank you for presenting, and thank you everyone for being here. So next week we don't have anyone signed up yet. So if someone who has not presented yet would like to, please let me know and sign up. I will put the link in the chat again. And the next chapter will be in we start going to functional programming, and it will be about functionals, which I have no idea what a functional is, so I'm very interested to find out what the difference between a function and a functional is. So I hope someone will sign up. If not, I will be bugging people personally, or I might just directly sign you up. So it's in your best interest to volunteer. And thank you all so much for being here again, and have a nice weekend. Bye.
Thanks, Jen.
And thank you one more
Thank
time to
you.
Jen. Bye.
Bye.